indicators. Okay, not simply through GDP. GDP, of course, is important. I'm not denying that. But GDP alone cannot ensure development. Okay. Dichotomous approaches, they became very ethnocentric in nature. And there is a threefold critique of such dichotomous approaches to modernization. One, ideological critique. Two, empirical critique. And three, methodological or meta-theoretical. Then, in this course, we are going to dwell upon the first critique, the first systematic critique from a more theoretical vantage point to modernization theory was by the dependency theory, the Latin American debate on underdevelopment. The dependency theory was an offshoot of two intellectual trends. One, neo-Marxism, and two, the United Nations Economic Commission for Latin America. When I say, I mean, we are going to discuss the distinction between Marxism and neo-Marxism in terms of imperialism and nationalism, classes, revolution and ethics, ecology, and so on. Okay, we are going to discuss Paul Barron's concept of not simply actual surplus but potential surplus. That's very important. Okay. We are going to discuss Stavenhagen's 7 erroneous theses on Latin America. We are going to discuss Brazilian experiences through the writings of Dos Santos, Chile's global Sankel's global model of dualism in Chile, in Argentina's experiences, many experiences from Latin America, then Africa, then Asia. We are going to look at. Then if modernization theory was formulated to cater to the interests of the colonizers or the advanced capitalist nations, then the dependency theory was propagated to celebrate the socialist ideology. If the modernization theory is known as a part of capitalist development trajectory, then dependency theory is known as a part of Marxist development trajectory or socialist trajectory. If the modernization theory was based on the theoretical premises of structural functionalism, then the dependency theory was based on the theoretical premises of Marxism. Okay. As you all know, structural functionalism is nothing but creation and maintenance of structures, institutions, and organizations of Western capitalism. I mean complementarity and reciprocity of roles in the social division of labor. When structural functionalism talks about complementarity and reciprocity of roles in the social division of labor, continuity of the hitherto existing power structures, Marxism looked at the dismantling of these hitherto existing power structures. These two, the modernization theory on the one hand and the dependence theory on the other, they were posited as two dichotomous theories of development. And is there a way to go beyond these two extremes? One, we are going to discuss when we look at beyond these two extremes especially in the Cold War period, these two were posited as two extremes. These two, I mean, modernizing theory and dependency. But is there life? Is there debate on sociology of development beyond these two extremes? We're going to look at E.F. Schumacher's Small is Beautiful. Then we are going to look at limits to growth thesis. We are going to look at paradigms lost, paradigms regained by Franz Surman in the 21st century. I mean, how development studies have taken a turn in the 21st century. Okay, we're going to look at these questions over a period of time. We are going to have another round of live session probably in the last week of September or first week of October. I'm sure all of you are very bright students. Please don't skip any weekly assignment. If you have any question, please raise these questions. If you want to send your questions to us through the portal, please send it to them. Send those questions to us. We are going to definitely write back to you. We have a very dedicated team of teaching assistants who look after these questions and answers. If you have any question, please raise this now, or else you write to us so that we can get back to you. Is there any question? No. Okay. Thank you very much. Please do well. Take care. Thank you.
यस मैडम, मैडम यस, हाँ लाइव हुआ क्या? ओके ओके, तो देन आई कैन स्टार्ट, ओके आई कैन स्टार्ट, ओके फाइन, यस ओके, no problem, no it is not that, but we accordingly that time will increase now, that because I have to complete about 1 hour, okay, so the delay you can go by different percent, no? Chalo kahan hai, where is that my folder? Okay, I will go to that one now. Okay, let us see that I'll go one by one up to 30, basically 30 lectures, small lectures we have covered, and I just go about that. We told the assignment problem. This is very descriptive type of lecture. I told the history of industrial engineering, okay, operations, research, definition, that type of thing was covered in one lecture, okay. Then I told about production planning and control, okay. There may be also some assignment problems are there, mostly descriptive in nature, and some type of amount of material requirement planning. Nowadays we have software for bill of materials, etc. And we have, yeah, so this was mostly that descriptive type of thing. And then finally we told about product design, okay. 2 lectures we conducted about product design. Then we told about job-based flow production methods. Then we told about work study, work sampling. Now work study, etc., when it came, then some mathematical concepts were also there, that one should see. Work studies, say suppose these are the flow charts, okay. Suppose these are symbols, huh? Okay, so this is yes, so let me share that thing, yes. So this is this one, let me share. I think I some slides so that you can see some of the slides, okay. Select entire screen, yes, entire screen, okay, allow, okay, yes, okay. I think that my screen is shared, and now you just say that lecture 2 is okay, lecture 6, lecture 6, okay. Are you able to see my this one? Anybody, madam? Can you see my slides?
Yes, yes, sir.
Okay. Yes, work study. Okay, work study. Okay. So in the work study, we said that we have the symbols like which operation will happen after what time. Transportation means we show by arrow. Inspection means that we show by rectangular that thing. And storage means it is by internal triangle, inverted triangle. Like that type of thing we discussed. And we said that there are different techniques for work measurement. So there is one equation, okay. That equation actually you can keep in mind, that suppose we have to find out standard time for some event, okay. So it should be formalized observed time into rating plus allowance, okay. Like how the example is that suppose observed time is suppose you go from one place to other place, and it took you 20 minutes, okay. But that day maybe the traffic situation was basically not good, okay. So you can say rating, okay, that means traffic was something rating, traffic got rating of 0.5. So 20 into 0.5 means actually it should take only 10 minutes. So standard time comes like that. But you have to add plus rounds also. That means 1 or 2 minutes extra you will add. So that is the concept, that standard time means observed time into rating means the person from you are getting the information, what is his or her rating, depending on this will come, okay. And so observed time 5 minutes, rounds I give 15%. So standard time I have taken 5 plus 5 into 0.5, okay. And work sampling also I told, that means you do that some activity, and maybe that you can do the work sampling type of thing, that suppose I open the system and I keep talking on the MS this one Google Meet or Zoom or this one Teams. So maybe out of 100 times, maybe 70 times everything was fine, but 30 times there was a problem. So that means you can say that 70% efficiency is there, okay. That means it is as simple as that. You can say that 70% efficiency is there of this system, okay. So we can find out that one. So we have done this also, and then we will go to this one. Suppose work sampling, yeah. So in work sampling I told in detail, it is this one work sampling, simple number observed in classification divided by total number of observation, and there is standard error of estimate, that means P average into 1 minus P divided by N. So by that you find out SP, standard deviation type, and depending on the confidence level you can take the value K and you can do that way. So this is again this one. Then I told about ergonomics thing. So this is mostly descriptive type topic, ergonomics, how it is important, what people are doing. See, it is hand rest by wood and something, this one. So now what happens that here, then lot of mathematical things were in inventory. In fact, in some books of operations research also, inventory topic is included, okay. So how to minimize inventory, how we should not take many things at one go, and suppose you order at Q and then average inventory is this much, and then you have some formula, annual inventory, economic order quantity, and based on that, reorder point, that means when should I order, and production order quantity model, and these type of things were discussed in inventory model. Then what we did that here, in inventory we studied extra also, because a lot of things may be there that sometimes you may have to take decision. There may be discount, although you may think that if I order less quantity it is okay, but there is a discount also, so you should order more. Say for example, I am using a shaving razor. Now one razor is casting, it is use and throw type, 25 rupees, okay. So one is costing 25, but if I purchase 4 at one time, so then it will take only 70, basically 25 rupees in 4 items. So therefore 75, in 75 I am getting 4 razors. That means 80, one razor is now costing 75 by 4, that means 18.75. But otherwise, if I purchase individually, then it will be 25 rupees. So 25 minus 18.75 means 6.25. So 6.25 rupees, advantage I am getting. But you know that you have to purchase 4 pieces together. Like that in industry, that type of situation comes. If you take the material in bulk quantity, then it will be advantageous. And this is so quality discount model. That is called quality discount model. Then probabilistic models and safety stock. We keep safety because the things are uncertain, and then we do that. We will discuss more about this at the end of the operations research, okay. Right now we said that even ABC analysis, there was very good thing was ABC analysis. I also keep paying attention to ABC analysis. Whenever you have something A class, B class, C class, okay. So item A classes items are expensive and they are less in number. So you should pay more attention to that. We keep seeing that type of thing. Sometimes somebody brings the bill to me, then and I want to see that what is that thing. I see that the costly items, the small items, I don't bother. Okay. Similarly, if I hope to reduce the budget, I will target on the big items that where the cost is going. The small items we will not pay attention. Then we said that about supply chain fundamentals. Supply chain is very important, and here we said that in this one, supply chain is means okay, that raw material, then producer, then distributor, after that retailer, then customer. That's how we get the things. But nowadays, if we have that something, okay, evaluation of this one, okay, ethics in supply chain management, components of MRP, digital supply chain, Internet of Things, okay, how internet. See, this is suppose you have 3D printing, then supplier to distributor, it can go straight way. That means manufacturer is not needed because that thing can be made by 3D printing at distributors place. In fact, if we can put small printers, then we can give from directly supplier to retailer. That type of thing is also possible. This is this one. So I can give an example that even other example may be difficult to visualize at this stage. But suppose a newspaper, suppose only Anand Bazar Patrika is there, okay, or from some Kolkata, some newspaper has to come to Guwahati. Now naturally that daily it comes, okay, of course you can bring it by flight also. I must get the, suppose Indian Express, okay, or Telegraph, it is published in Kolkata. But what we can do that if we can put a printer in my house, then they can give the soft copy and immediately I can print out and I can distribute in whole IIT. So locally I can do that type of thing. So this type of model soon will come for various things. Right now you see even newspaper goes to many places, but with digitization, it is possible that you make something somewhere and then after that it can be distributed. Okay. So this is what this one. Then this is a very good topic. I say that it is called total quality management. If you know that if some system has to be this one, then you have to pay into total quality management. I can give the example of today only, that today our session was supposed to start at 4:15, but somehow because of the technical glitches, etc., that could not be done. So total quality management doesn't mean that, okay, I might have done very good teaching, I might have included material properly, mathematical things, TH might have checked properly, but computer system, okay. Now it may be the mistake of maybe computer center also, maybe the mistake of, that say internet service provider, any type of thing is possible, but it is this one. So total quality management, if you want that your course should be excellent, then everything should be paid attention. What is the internet quality? That means it is not only the teacher and students who will improve the quality, but even the supporting services, okay, like that. Suppose there is no power, suppose power cut. So total quality management says that starting from an attendant to general manager, everybody is responsible for total quality. If your workplace is dirty, then also that you are not doing total quality management. Once some vice chancellor told me that when I visit other university for inspection, I first check the bathroom. If the bathroom is dirty, that means the institute is not doing the job properly. So TQM, I should TQM axioms, I told commitment, scientific knowledge, and involvement. There should be commitment, there should be proper scientific knowledge. And in that context, I told about William Edwards Deming, who is called the quality guru. You can say he is a father of quality, total quality management. he gave many things and many points he has given, and he used to say that you should not discourage the staff people. You should drive out fear from them, break down barriers between staff areas, and all those type of things. And he said that he also told about 7 deadly sins. When I say that one sin that he, then people get amazed and they say that they get shocked that, sir, what are you doing? Performance appraisal, which is considered very good, that people say that, okay, if worker is doing, you take the performance appraisal, APR, annual performance report, and then give the bonus based on that. But you know, Deming was dead against the performance appraisal. Why he was dead against? Because in the performance, if you will give that 1 mark to somebody, then other person will get their demoralized. Okay, if you suppose I give a award to somebody, then other persons will get demoralized. Everybody might have done service. So he said that you try to improve everyone, and he, based on the, you know, that this one, he said use the statistics also, do the on-job training and all those type of things. But you should not say this type of thing that no, your performance is poor and you go this one. So this is what is the Deming's main thing. And then there were other quality gurus also. These are like, they said that you find out the cause and effect, Ishikawa diagram. Then statistics should be used. Deming has given many quotations also. He said that it is not only basically top management is responsible. He said a bad system will beat a good person every time. And it is security. Then Taguchi was there. Taguchi said that if you want to do something, quality should start from the stage of design itself. Okay, that means then only the quality can come. I can do in a course teaching also. Suppose teacher is really good, but the syllabus is not good, then how the teacher can teach properly? Means this is the, so therefore, if you want to have high quality course, syllabus should also be very good. Other things should also be good. That is what the concept of that. I give some example of some companies who are using TQ philosophy, TQM philosophy. Motorola, they are using Six Sigma methodology, that there should be very less defect and these type of things. So I told about total quality management. Then I told about this one, statistical quality control. A lot of lectures were given on the statistics, application of statistics. First, you should understand using the statistics, using pie chart, how much percentage this, total temperature between this range to this range. Statistics can be descriptive, it can be inferential. Descriptive will only describe that what is the average rainfall in Guwahati, what is the average rainfall in Meghalaya. But inferential statistics will make inferences, means because of this what is happening. Okay, so inferential statistics can be used for forecasting. So we said that based on the samples, we take decision and we do that type of thing. Sampling distribution, we set sampling error, and central limit theorem. I told you very good this one, that if you take large amount of data is there, and if we make the batches of say maybe 4 or 5 items per sample, if you take the average, then the average will be normally distributed. Okay, so this is hypothesis testing. That means hypothesis testing. That means suppose somebody gave the protein in the cow's milk. Okay, this is the protein in the cow's milk. Cow number 1 gave this, cow number 2 gave this, cow number 3 this, cow number 3 per liter protein is this, like that. And buffalo's milk, this is the condition. So it is not constant. There is a statistical variation. So naturally, this mean and this mean may be different, but whether that difference is significant or it is insignificant. Many times we do something. Okay, suppose somebody joins some yoga club, and then after that he says that, okay, initially you know that I used to work say 8 hours, and now I am working 8.5 hours. So whether that difference is significant or not, those type of things are done by statistical method. Like here you say 1.92 and another place average is 2.17, and then we say that difference is significant. But suppose one value is 1.92, other value is 1.93, then you can say, no, this may not be significant. It may be just by fluke, in what we call that in Hindi tukka. That means it is matching, okay, somehow. But this will be done mathematically. So by using the formula, okay, this much difference is significant, this much is not significant. Data table, how you make data table, and cause and effect analysis, okay, you make this type of diagram, then it becomes easy to do that. Histogram, Pareto analysis, scatter diagram, control charts we make. Control charts means we make the control charts for some classes. This is the average value, but the value can go here, value can be here also, and the values will be between two limits, okay. So what Deming and others are telling, that if it is between the limit, you should not go there, okay, that is the thing. See, suppose within the limit, okay, but once it crosses the limit, it is this thing. Suppose I have been assigned to take daily, suppose 55-minute class, okay, but sometime I took that 1 minute extra, sometime I took 2 minutes less. So based on that, you should not judge me, because there is a statistical variation. One person cannot do the same output. This one, someday he may be having some small cold and cough, but it should not cross the limit, okay. So something that my principal or head of the department should take action. If I have taken 55 hours was allotted to me, 55 minutes, and I finish the class in, say, 40 minutes. So that means, okay, it crossed the control limit. Okay, like that in product also, there will be this thing that you cannot say that the same quality will be there. Okay, you take any sweet from Haldiram, it will have some variation. One day it may be little better, one day it may not be this one. Mangoes also, if you purchase from market, there will be this one. So this is the thing. So we can draw the control limits. That type of thing we have understood, and we have seen that type of thing that was taught here in control methods. Then we say, we continued about that. We said that acceptance sampling. Okay, sometimes we say that based on the sample, we will take decision about that thing. In fact, knowingly or unknowingly, we are doing that type of things. Maybe mathematically we are not writing. Suppose I take examination of a student. I am giving only 10 questions, but I am basically, based on that, I am judging about the whole syllabus. In the whole syllabus, there may be 1,000 questions, but 1,000 things I cannot ask. So I am only taking random basis 10 questions. Out of 10, how many he has answered? Based on that, I am taking the decision. So that is why this is called acceptance sampling, that, you know, I will accept all that thing. Even the rice also, there is a proverb that whether the rice is cooked or not cooked is decided by taking 1 grain or 2 grains. Based on that, we say that yes, whole rice has been cooked. Okay, but it is also possible that sometimes mistake. Sometimes we have seen also that rice was cooked, but in between I found that in my dish, means my thali, there was one thing that which was a little bit uncooked also. That is possible, but you know that, so there is a probability. That means there is a risk also. So we take based on the acceptance sampling. So I said that based on the probability theory, you can take the decision. You have the operating characteristic curve. That type of thing was told in acceptance sampling. We can have double sampling plan also. That suppose one sample is not proper, then we try to do other sample. And then we have gone to this one also. We have gone to control charts, other in detail, and we said that there is a, see, this is what is the advantage in the control chart. We can find that it is really a serious thing which you should look, or it is just by, say, something like that. That suppose you say everything within the control chart. That means you can say that this is random variation. But suppose something is totally out of this one, so that is called assignable cause. That means assignable cause. Okay. So X bar and S chart and P chart. P chart means here we will say total number of defectives divided by total number of items inspected. That 5 items are defective, 95 are good. Okay, so P becomes 0.05 like that, and we have the chart like that. So control charts are also used, and Six Sigma plots, PPT. So Six Sigma is basically little bit mathematics also and little bit philosophy also. When we say that follow the Six Sigma, so that means you will not tolerate defect. Suppose aircraft is flying. Now the pilots should have more quality than the even Six Sigma. Six Sigma means suppose you have 1 million times something goes to only 34 in 1 million means 10 lakh items you do and only 34 defects are there, then that can be called Six Sigma. So Six Sigma is a type of philosophy. And Taguchi actually told that type of concept, that Taguchi's concept also in any time in Viva, etc. We can ask that type of thing. What is the concept of Taguchi's last function? Taguchi told that if you have been given a target to make something, so then if you deviate from the quality target, then accordingly your loss increases. Okay. So suppose you can say that I need, if I have ordered 1 kg and suppose 1 gram, but you brought 1 gram less, 999 gram only you give. That means in a way your quality has reduced little bit. And 998 means even it further reduced. That means basically Taguchi says that you try to do the things as per the target only. So that is what that concept of that. And as you move away from that in a parabolic manner, that means your loss will increase. That is not. That means suppose deviation of 1, so loss is 1, but deviation of 2 means loss is 4, not 2. It is 4. It will keep on increasing. So Six Sigma concept is there. I have already told that Six Sigma, and he said that it is how much that if you say 3 Sigma level, then we can tolerate many defects. But in Six Sigma, yes, I said I think by slip of tongue I might have said 34 defect rate per million, no opportunity. It is not 34, it is 3.4. Is it not? That means 10 lakh times something went. Suppose 10 lakh, that times the flight took place and only 3 times there was some crash or something. That type of things should be there. That is called Six Sigma. Even in the aircraft, we want even more. No. Is it not concept of zero defect? It means we cannot tolerate. But you see, in spite of the best effort also, that these problems do take place. Very experienced pilot, they also cause this one and their own life coach. So Six Sigma methodology has got some method also. You have to define a problem, then you measure the problem, you do the analysis, you improve it, then control it. Okay, that means first to define what is your target, then you measure, right? Define. My definition of aircraft operation is what? That here to means Guwahati to Delhi, flight should be without any issues and it should reach in time. So I have parameters, many parameters, that whether was there AC problem, was there too much turbulence, did the passenger feel any jerking, did it reach in time. So if quantify those things, that what should I quantify? Don't say subjective way. Don't say that no, this journey was not good and this journey was. You tell me in terms of the quantification that what was the problem, why this journey was okay, 5 times you face the turbulence problem, like that. So analysis, then improve, then control. So these are some mathematical things here also, like defects per million opportunities, total defects, total units, opportunities per unit time, and we have discussed about that. In Six Sigma, we give the belt, just like in martial arts, we give belt. That means white belt is very, this one basic understanding. At least you know that what is Six Sigma, then you get white belt. But black belt you get, then you become full-time improvement expert. Then you get this one. Then there are quality standards, ISO 9001, 2015. quality management system, that how the quality management system should be there. So key features are there. This standard you can see from internet, you can do Google, you can get some features of that, and you can get about that. Then OSHA, if you in your company, occupational safety and health administration standards are there, those should also be followed. And this is the thing we have told about the quality. And then I told about forecasting, that how should I predict what should be the market demand next year. Very difficult. It is not easy task. We are not able to do forecasting also properly, but mathematically we are trying to do some attempts, and most of the time moving average. That means we take the average only, but maybe past 4 months, okay, average. So next month it will be again that past 4 months. So average keeps moving. That is why moving average. Otherwise you use exponential smoothing models, and then we can have other type of, these are forecast errors. Linear models, you can make use of linear regression, okay. So here forecasting too. So this is about, yes, suppose we can fit regression, that what is dependent on what, we can fit equation, y is equal to a plus bx. Why it is so that, suppose we can find out, is there any relation between the age and the number of time he spends in the mobile phone, that type of thing. So we can have some equation. So mathematically we do that thing, then it becomes a regression. We can have many factors. We can use the fuzzy method. We can have market many things. So that was forecasting. Forecasting is important topic. Then what happens? Scheduling. Scheduling means we have to, how the job should be done, how it should be scheduled. We have got so much work, so one by one we have to do that. Job scheduling, that means whenever we get some job, I got A, B, C, D, which one I should make, A, B, C, or D. So we have to see the methods. There may be many methods. You have to see what parameters you should see, that you should do that. Sometimes we want to say due date, based on due date, earliest due date, or first in first system, or first come first served, and shortest processing time. Many methods are there, and I have discussed in detail about that. So this is in scheduling. And then there is an important topic here, that in the scheduling itself, we went to assignment also, assignment model. Suppose scheduling, critical ratio. We defined a critical ratio, time remaining divided by work days remaining. See how good thing it is that, you know, if you know the critical ratio. Suppose I have to do some job, and I know that still 10 days work is left. 10 days to total work is left, but I have 30 days. Suppose on 30th September, today is 1st September, on 30th September, I have to do some task. If continuously you do, then it will take 10 days. So basically now what happens? So it will take 10 days. So time remaining is 30, but work days remaining is 10. So critical ratio has come 3. Okay. So job, one who has got critical ratio more than 1, there is no problem. But one who has got less than 1, that means there is a problem. So that's how that you can always calculate as a manager. You can do that. Which job will be having more critical ratio, which job have less critical ratio. Sequencing also, that suppose there are 10 jobs to be processed on 4 machines. On one machine there are 10 ways, and on 4 machines there are so many ways. So naturally it has to be done by some rule. So Johnson etc. have given some algorithm. Like suppose you know 2 machines are there, so they say first you process shortest time job A in machine 1, and then longest time is assigned to other machine. Okay, like that. So this is the shortest time in is 3 job B. Shortest time is 3. Okay, here, but it is in machine 2. So you process it last. Okay, so that is Johnson's rule. So Johnson's rule is used for scheduling, and then you can reduce total make span. We use the term make span. Make span means total elapsed time. That time when last job finishes on machine B. That is called make span. And then we also discussed assignment problems. Okay, this is topic of given operation research also. Assignment problems. How we did assignment? Involves tasks or jobs or resources. Assignment method. So assignment example. Suppose product A, I can do it on printer 1, printer 2, printer 3. But rates are different. I have got 3 jobs and 3 suppliers. I have got 3 managers, but I have got 3 hostels. So which manager should be kept in which hostel? Is it not? I have got 3 shops in, is it not, production quality control, and another shop is also their marketing. So who should be head of which one? That type of thing, systematically you do so that overall benefit is maximized. That is by assignment method. Okay, so there is a simple method. It is very easy method. This is called assignment method. This is basically heuristic type of method. Okay, so this heuristic method can be used, and this by heuristic method we find out that which job should be assigned where. So I have given number. I told about that means production line should be balanced. How should we do? Suppose station 1, it takes 10 minutes and station 2 takes 1 minute. If you go to any office also, you might be seeing that you have to take one paper to one babu, then it will go to other babu. So that one man takes 10 minutes. Then other person takes only 1 minute. So that means this is not balanced. Because one person goes 10 minutes and he does only in 1 minute, so 9 minutes he is idle. So you should try to do some way that work should be distributed so that he should also get, say, something 5-6 minutes and other person also get 5-6 minutes. That is called assembly line balancing and something. Line efficiency, cycle time is available time by customer demand. Okay. Balance delay is 1 minus efficiency. So all those type of things we have done. Deciding how many stations are needed. You can say that in the office context, how many persons are needed, how many products are needed, and then break-even point. This was very interesting thing, break-even analysis. I got here that break-even, that means how much contribution means sales minus variable cost. That is called contribution. Okay. So I got this one. See, we always keep asking that when you will achieve the break-even. Suppose I have opened some sweet shop. How many sweets per day I should make so that I should not have loss? Because suppose my even electricity and rent of shop itself will be high value. If I make less quantity, maybe I may be making profit in one quantity, but overall I will be getting loss. And very interesting thing was there that even if you are getting loss in some unit, you should keep making it as long as the contribution is positive. That means only pay attention to variable cost. Suppose I make some sweet this one maybe product, and the product is its variable cost is 10, but as such 10 rupee, and I am getting, I can sell that in the 11 rupees. I can still get 1 rupee contribution, but overall but on that item you can say I am making some loss also, because I fix up the price of the product based on the fixed cost also. fixed cost also, fixed cost may be there. But the thing is that as long as it is giving some contribution, that means it will contribute to fixed cost. So it is worth making it. So sometimes we observe that, that if somebody is saying that, suppose a person says that here Delhi to this one, suppose Guwahati to Delhi, airfare is suppose 8,000. Okay, 8,000. Okay. Why? So suppose I ask the airlines person that if I give you only 6,000, will you be making loss? So they say yes, of course loss, because so I say because we are making only 1,000 profit on each ticket. Okay, but profit how they calculate? That means they calculate the cost of the aircraft, etc. Also, that is also included in that. Okay, fine. So now what I am doing that, suppose I say, okay, so suppose you may, but I have only 6,000. So there will be loss. So should he take me or not? But he should still take me, because if by my sitting in the aircraft, fuel will increase only slightly, and some maybe snacks he has to do. Overall, it may be only 4,000 rupees expenditure for him. So I am giving more than that. So at least I am contributing something to fixed cost also. So that means I should be given a ticket in that. Okay, that is the idea. That even if you are giving that, but it is coming, it is something like that. Okay, is it not? Like you may say that, okay, if I organize some, even say big some cultural function, let us say Durga Puja, I fix up that somebody is this one. I say that, okay, if everybody will pay 1,000 rupees, then only my thing will be sustainable and I will not have any loss and it will be all right. Okay. But somebody says, no, I'll give only 100 rupees. If you want to take it, take it. Should I take it? Not. Question is, yes, of course you should take, because for 100 rupee thing, he will come, but he himself will take the prasadam of maybe 50 rupee. So 50 rupee still is there. That will be used for other items. Although overall, if he gives 1,000 rupee, then your expenditures will be properly managed. So cost calculation, price calculation is done in different way. There we consider variable cost as well as we consider the fixed cost. And based on that, we decide that what should be the cost. But in contribution, we just say sales minus variable cost and we decide by that. Okay, so we do that break-even point. We have said that fixed cost divided by contribution, and we have given a lot of examples about that type of things. We said profit volume ratio means contribution divided by sales, and we are making very much inferences about that type of thing. So this is how that it goes. And break-even point 2, it is means we give second lecture, we again discussed break-even can be based on the value, it may be based on the quantity. Okay, break-even point in units, break-even point in value, and we have got some very nice formula here. You can practice these, and we are telling using a selective result sintering how do we do cost estimation here. We have given a paper also that Dr. Futi Sharma has made this one, so that also you can see that here. Utility assessment, many methods are there. How you can calculate that? Say suppose you are making this time of items. Now you have to take various type of cost into consideration, and this type of thing is coming because of uncertainty, because cost is uncertain, and then you make the inferences. Okay, so now what happens that here now, but you have non-quantifiable benefits that also has to be seen. Company's mission, focus, likelihood of success, market conditions, customer goodwill. Okay, that also has to be seen. Then we talked about industry 4.0. Okay, industry 4.0. What is industry 4.0? Industry 4.0 means mostly automation with the help of the big data. In industrial automation, many things we discussed. Okay, how it went. Just see in the first industrial revolution, we were making only machines. Machine means big thing. Some like Smith, poor person in the village, he's putting the hammer by hand only. And there he using that pneumatic hammer, hydraulic, this one, steam power hammer. So this difference was there. Then in second industrial revolution, electricity came, mass production came. Third industrial revolution, CNC machines, internet, those type of things, robotics. But in fourth industrial revolution, cyber physical systems. Then Web 2.0 means even social media, smartphones, these type of things are there. Additive manufacturing. Now we have apps. We have even cylinder booking. Everything is being done by app, automatic. I booked it yesterday and today I got the cylinder. Digitization, additive manufacturing, smart factory, import these type of things. So industry 4.0, role of cloud computing. That means everything you may not procure. I need not procure all the software at my office. Who will manage them? But whenever I need, I can do that from internet. I don't have Photoshop myself, but Photoshop thing I can do. In the Google, I go and type that thing, and then Photoshop is available. There I can do that type of thing. This is cloud computing example. Online optimization with the help of cloud computing. So these type of things we have to do that. This becomes industry 4.0, and online learning, we keep doing big data, how to take data. Data is coming, we are making use of that. Companies are keeping the data, that who is delivering how much, and when we should send mail, what type of items. Facebook is continuously seeing that which type of post I am spending more time, and they try to show those things more to me. This is called big data, and they are also putting that example. They are taking the influence. What type of thing I am liking, what type of shirt I am wearing. So they are keeping that type of record, and they are giving to customers, companies, so that they can plan accordingly. So this type of thing, but there are many challenging issues in big data. There are outliers, means wrong data. Then there is data security, then avoiding data explosion, then dealing with scarcity of data, assessing veracity, then efficient way of prediction. How should we do that? So how can digital manufacturing be reality? Cloud-based design and manufacturing. Actually, it is written CDBM. I think there is a misprint here. It should be CBDM. Okay, cloud-based design and manufacturing. This is CBDM. Okay, that can be corrected. Modeling methods. We have to model also mathematical. Nowadays, industry work. Try to think that can I apply any mathematics? Can I do some calculation? Can I do by that type of thing? So we have rolling mill. I can put some sensor. I can get what was the temperature. Based on that, I can say that whether it is doing properly or not, inverse way. Residual stress is machining. Softwares are there. They can do the things, and we can do. How do we estimate residual stress? So this is the type of very this one, and multi-scale modeling. So all these type of things are there, and yes, little bit I will tell more. Okay, am I still connected? Where is that thing? This is PowerPoint presentation. No, this is not here. Yes, connected now. Okay, okay, fine. So yes. So industry 4.0, that means we are living in the age of industry 4.0. That's why nowadays, even the ticket checker, he's not seeing that ticket actually, hard copy. He just comes and asks that, okay, are you so and so? Are you the Dixit? Yes, it is everything. Because the ticket, everything, message is in my mobile. If you have the mobile, if you have a smartphone, which is your basically computer. Basically, computer is not only that laptop. You are moving with always a computer in your pocket. A smartphone is basically a computer, and this computer can keep all the data. Your ID is also in that. Your whole details are there. Aadhaar card can be there. Now DG Yatra. Now no longer you have to carry out any I card. This one. Now DG Yatra app is there. You go to the airport, and if you just stand in front of the camera, camera will recognize your face, and he will say, okay, yes, that is the thing, that camera will recognize the face. You can show that DG Yatra app thing, smartphone, they will say, okay, okay, yes, yes, allowed. Gate will automatically open. Even the security guard doesn't have to open the gate because sensors are there. So that is what it is, a IoT type of thing, Internet of Things, okay. They are connected, and then you go to security check, there also everything is there. Now he is not seeing your boarding pass, everything is in DG Yatra app. This is Industry 4.0. But what is 5.0? 5.0 means that you have to see, if we become that much automated, then human beings will not do any work and they will become unemployed. So in Industry 5.0, we are thinking about human being. This is Industry 4.0, 3D printing, etc. But then Industry 5.0 means human-centric. It should not be that I should become this one totally useless. It should use me. My power should increase, okay. That means I should still be respected. My thing, okay. I have come, I am speaking. But if you want, your system can be this thing that I am speaking little bit in poor English. System automatically has a translator. It can translate and make it a very nice speech, okay. That type of thing should be there. But my involvement should be there. It should not be that, okay, recorded message of somebody has been put. AI tool, artificial intelligence, it has told that then, I will become useless. So human-centric means everybody's human being should be utilized. Our clerks will not lose the job. Our office staff people, our peon will not lose the job. Only thing that other machines will be working together with that. So that is called, we can have cobot. Suppose peon is going from one place to other place, he may forget. So we will provide a companion to that peon. We say that, okay, this is a cobot. There is a terminology, cobot. Cobot means co means together, bot means robot. So cobot means together. That robot goes with that person. He said, chalo chalo yaar chalte hain. Na? It will be intelligent. It will even take that in between. He may give tea also. And he will say, okay, walk down, and he will increase the efficiency of that. So human-machine interaction, all those type of things. And then what Industry 5.0 is also seeing, sustainability. That if you are making that type of fully automatic system and too much energy you are doing that, whether this system will be sustainable. It should not happen that you are spending that much amount. Your future generation, your sons and your grandson will not have anything. So it should not be that type of thing. So Industry 5. And resilient industry means you can adapt to this one. So why advantage of this one? Human-centric. I want my touch, okay. Don't make that type of AI that it is very standard, this one. If I have got some habit of some accent, little bit, that also should be preserved, so that you can say that, yes, yes, this Professor Dixit is speaking, because it is like that, okay. So that means personal touch. I can know that. So it is a challenge. Now they are paying attention to these type of things also. So that's why even humanities and social science people, psychologists, they will also come into it. And enhanced innovation, always do innovation, better work conditions, social responsibility. That is Industry 5.0. Aligns technological processes with societal goals, including inclusion, gender inclusion, that everybody. It should not be that, okay, no, in this job females cannot work. Why you make the system by technology so that females should also not face problem. You cannot say old person cannot do that. Now you see that companies, earlier when new phone came, mobile phone, then old people were not able to operate that phone. But you see that now old people are also able to operate because they have made the system. Even I can type in even Assamese and Hindi very easily. Assamese also, because they have given keyboard. I type in English, immediately it translates in Assamese. So my culture is preserved, my dignity is preserved, my social. This one, I don't have to become that Englishman just using a smartphone. Nowadays, you see in Facebook, many posts are coming in the local languages. So this is the what these are the comparison table you should see, because based on that some questions are also there. Industry 4.0 says automation, efficiency and productivity produce too much, but here industry 5.0 says human-centric, sustainable and resilient. Role of humans, industry 4.0 say minimized. Everything is done by machine. What should I do? But here in industry 5.0 central, you have to do collaborate with machines. Machines should be like your friend, okay, like a wheel and the horse. So smart mass production, here smart mass customization, is it not? And ethical considerations really addressed, but here industry 5.0 ethical this one. Industry 4.0 was thinking that we produce a smart factory. A smart factory means vision is what? There is one factory, no human being. But here, there should be harmonious coexistence. Without human being, how the company will look? So people, planet, company, machines should be together. So these are the things that we are targeting nowadays. Attention has been paid. And then we are having the goal of big data. Big data will be big data and analytics. Big data definition. Big data means it is relative. For me, 1,000 data may be big data. For you, maybe 1 million data may be big data. So big data has property, volume, velocity, variety. Velocity means reliability, value. And then these are some interesting facts I told. See how many messages you are sending through WhatsApp. 100 billion messages are sent every single day. So growth of data is tremendous. I have given some questions about these type of figures also. What is zettabyte? Means 10 to the power 21 bytes. Then you put 1 and you put 21 zeros. Then you get this one. Scientific notations, million, billion, trillion. In fact, trillion. This one we say we will have 5 trillion economy. So 10 to the power 12 trillion. And these are the things need for big data in manufacturing. Everybody may not be having that big workstations and other type of things. So through Hadoop, you can store the data. I am just naming these things, but you have to see in the Google. You have to, if you want to use that big data analytics, and using that you can make that. I told something about regression Cook's distance. I said that one student has done some thesis on big data in machining, and then machine learning. That means machine automatically understands. Okay, like machine learning, many things. Yesterday, some doctor came to me from AIMS, not doctor basically, maybe 5th year student who is completing his MBBS course, and he's doing a project, and he's involving me in that. He said that suppose some boy's 1 year, 2 year old child is coughing. So by cough, I can know that whether it is a pneumonia or it is bronchiolitis. Okay, it is bronchiolitis or pneumonia, like that he told. So this type of thing is happening. So how can we know that? We will first train with large number of data. He will tell that this patient was healthy, this was having pneumonia, how was the cough sound, and then using machine learning, I'll be able to predict that this one. So machine learning can do classification. Machine learning can be supervised learning. Here we can regression, means we can find out a functional relation, and we can do classification, and we can also do clustering, association, unsupervised learning. That means you just give me data. You do not tell that what type of data is something, but machine will understand, it will segregate that this data is one type, this data is one type. So naturally, this might have come from different source, this might have come from different source, like that. So input data, supervised learning and unsupervised learning. And then what happens? Avoid wall fitting. There are some methods. Okay, these type of things. We make a confusion matrix, predicted value, true value, accuracy, total positive predictions, total negative predictions. Total positive means true positive. Means positive, true positive means what? That person was having positive and you predicted, yes, it is there. And true negative means person was not having cancer, you predicted not having cancer. So TP plus TN divided by TP plus TN, but there will be false positive and false negative. So it should be yes, yeah. 1 hour ho gaya. Concluding. Just in 2-3 minutes, I am concluding. Okay. Yeah. So yes, 2-3 minutes, I am concluding. Okay. Yes. Any question is there in that? Open that thing, YouTube. Just check. Any question? Any question if it is there? Otherwise, no question. Okay, fine. So this is machine learning, and then we told about IoT, Internet of Things. Okay, that I have already told. Okay, Internet of Things. Okay, that was told that how mechatronic systems. This was there. Okay, I will not spend much time. These are descriptive type of things. Like a story you can study, even from Google you can see smart factories. What is the definition of smart factory? Through the cyber physical system, IIT, digital twin, digital shadow, and then finally I told about in much detail about digital twin. Now we are making whole thing of a digital twin challenges and roadmap. So we said that okay, digital twin, digital shadow. Digital twin means it is a two-way communication. And digital shadow means one-way communication. That means you get the data from this one, but you cannot actually give the data to this one. So digital twin, digital model. So digital shadow means I can take the feedback from the, suppose I make a digital twin of a bus. So bus is in my computer and bus is also in the main market. So whatever is being done in the main market, that type of data is coming in my system also. But I cannot control from here. If we have this type of situation, that is digital shadow. Means I am just getting a shadow. Just like by touching the shadow, you cannot stop the person. Okay. But digital twin means I can do the change to bus from here. If I want to do some, if I want to stop the bus, I can stop from here. So these type of things have been discussed in industrial engineering, and now we will discuss operations research afterwards. Okay. Thank you very much. Okay. So I am concluding now. Okay. Yeah. Fine. Okay. Yeah. Hello, madam. Should I close now? Yeah. Yes. Fine. Fine. Okay. I am leaving. Now I am leaving. Okay.